Hello guys, my name is Pino, and in this video we'll be going through question 3 from the November 26, 2020 N4 Mathematics question paper. Question 3.1, the width of a rectangular field is 5 meters less than the length. The area of the rectangular field is 300 meters squared. Each side of the field is increased by 2 meters. Determine the value of the increased or enlarged area. So we are told that the width of a rectangular field, so this width of the rectangular field is 5 meters less, so less than the length. So this is our length x, but the width is 5 meters less than the length. So we have x minus 5, so it's is equals to y. So y is equals to 5 is equals to x minus 5. It's 5 meters less than the length. So the area of the rectangular field is equals to 300 meters squared. So the area, we have it as x multiplied by y, and we are told that it's equals to 300 meters squared. So before we can go there, let's first solve for x. So area is equals to, so xy is equals to 300, but we know that y is 5 meters less than the length. So we have x minus 5 is equals to 300. So this will be equals to, so we distribute the x inside the parentheses, so x multiplied by x will be equals to x squared, and x multiplied by negative 5 will be equals to negative 5x. We take this 300 to the left, it's going to change sign from positive to negative 300, and there will be left with 0 on the right hand side. So let's, to solve this, let's use the quadratic equation. So we have minus b plus or minus b squared minus 4ac, or if you can factorize this without the quadratic equation, go ahead. So we have x is equals to minus b is equals to negative 5 plus or minus b squared, which is negative 5 squared, minus 4a is 1, c is negative 300 divided by 2a. So our x will be equals to minus 5 plus or minus, plus in this case minus 5 squared minus 4 of 1 into negative 300 divided by 3a divided by 2a. So our a is equals to 1, 2 into 1, so our x will be equals to 20, or so when it's negative, so when it's negative, x is equals to negative 15. So this one will be inadmissible. So now we are left with x is equals to 20. So the reason why that one is inadmissible is because of that negative sign. So from here, we have to determine the value of the enlarged area. So we are told that each side of the field is increased by 2 meters. So we can so this one, originally x is equals to 20, and so this one is 5 meters less. So 5 meters less than 20 would be equals to 15. So this is the original area. So we can prove by saying 20 multiplied by 15, and we know that we're expecting 300. So we get that 300. So the second set of instruction, each side of the field is increased by 2 meters. So the original was 20, but is increased by 2, and the original width was 15, and it's also increased by 2. So this will be equals to 17, and this one will be equals to 22. Determine the value of the increased or enlarged area. So area 2 will be equals to 17 multiplied by 22, and we are expecting it to be more than that 300. So this will be equals to 374, and this is in, the area is in meters, so this will be meters squared. And this will be our answer for question 3.1. Question 3.2, we have to make n the subject of the formula if a into r raised to the power n minus 1 divided by r minus 1 is equal to s. So we are expecting to use logarithms. So let's multiply. We multiply both sides of this equation by r minus 1, so that r minus 1 will cancel out with that r minus 1. And we'll have a into r raised to the power n minus 1 is equal to s into r minus 1. We divide both sides by a, so that a will cancel out that a. So we are hunting that n. So you have r to the power n minus 1 is equal to s into r minus 1 divided by a. So we take this negative 1 to the right. It's going to change sign from negative 1 to positive 1. So we know our logarithmic law. So if we have ln of a raised to the power 2, this will be 2 ln a. So this ln is going to be dethroned from the exponent to the base. So we expect the same thing. So if we have ln of r raised to the power n, we'll have n ln of r. So we introduce the ln, but we cannot just introduce the ln on the left without introducing the ln on the right. So what you do on the left, you also do on the right. So this, as per our logarithmic rules, will be n ln r So we divide both sides by ln r, so that we can have, so that ln r will cancel out with that ln r. So we'll have n is equals to ln of s into r minus 1 over a plus 1 all divided by ln of r. So that's it for question 3.2. Question 3.3, we have to solve the unknown if 3 to the power 3x plus 2 is equal to 12. The only unknown in this case is the x. So we have to solve for x. So we know from our exponential laws that if you had a, b plus c, this will be equal to a, b multiplied by a, c. So this will be equal to 3 raised to the power 3x multiplied by 3 raised to the power 2. Remember that when the bases are the same, we add the exponents. So from here, we divide both sides by 3 raised to the power 2. And we'll be left with 3 raised to the power 3x is equal to 12 divided by 3 squared, which we can write as 9. So 3 raised to the power 3x is equal to 12 divided by 9, which will be equal to 4 over 3. So from here, we have to use logarithmic rules again. But before that, we can express this as 3 raised to the power 3, which will be 27, but we still have to remain with the x. So from here, so our logarithmic laws again, so we know that if we have ln of 2 raised to the power 4, this will be equal to 4 ln 2. The 4 is gonna be removed from the exponent to the base. So we introduce ln both sides. What you do on the left, you also do on the right. So we'll have x ln of 27 is equal to ln of 4 over 3. We divide both sides by ln of 27, so that ln of 27 will cancel out with that ln of 27. So x will be equal to ln of 4 over 3 over ln of 27, which we can write as 0.087. So if you want to check if you made a mistake or not, you can take this 0.087 and you substitute it where there is x plus 2. So we are expecting to get a number which is close to 12. So this will be 11,988, which is pretty well close to 12. Question 3.4, the impedance of a circuit is given by the equation Vt is equals to Vt over V3 plus V1. So calculate Vt if V1 is equals to 3 plus J and V2 is equals to 3 plus J2 and V3 is equals to 2 minus J3. Leave the answer in polar form. So we have Vt is equals to V2 over V3 plus V1, and V2 is equals to, so Vt is equals to 3 plus J2, all divided by V3, which is 2 minus J3, and V1 is equals to 3 plus J. So Vt is equals to 3 plus J2, so we add what we have in the denominator, so these two, so the real numbers, 2 plus 3 will be equals to 5, negative, so the imaginary numbers, negative J3 plus J will be equals to negative J2. So from here we can convert this. So we first have to, so let's focus on what we have here on our numerator. So let's call it the radius 1 will be equals to the 3 squared and the 2 from the imaginary J. So 3 squared plus 2 squared, which should be given as 13. And to find the corresponding angle, we have arctan of y over x, opposite over adjacent. So theta will be equals to arctan of the opposite is the 2 and the x, the adjacent is the 3. So arctan of 2 over 3 is equals to, okay, this is in radians, so we have to convert to degrees. So this will be equals to 33,69 degrees. So we have to remember to convert our calculators to degrees. So for R2, what we'll have on the numerator, on the denominator, so we have the square root of 5 squared plus negative 2 squared. So for our denominator, this will be equals to the square root of 29. So for theta, we have arctan of y over, so we can call it theta 2, arctan of y over x, y1 over x2 over y2 over x2. So the y is equals to negative 2 and the x is equals to 5. Negative 2 over 5, and this will be equals to negative 21,8 degrees. So let's verify. So we can use our calculator to determine this, but I'm not sure if you use it this way you'll get all the marks. So shift and the positive for pole on top, the 3, and then shift again, the closing bracket or parenthesis. So you plug them as they appear, the 3 and the 2, the 3 and the 2. So this will give us r is equals to, this is equals to 33,66 and the theta is equals to 33,69. So I believe that the square root of 13 will be equals to 3,66. So if not, then we made a mistake somewhere. So the square root of 13, 3,66. And for the denominator, we have shift the positive 5, shift the closing parenthesis 5 and negative 2. So we have 5,388 and negative 21,8. So the square root of 29 should be equal to 5,3. Okay, so we didn't make any mistakes. So from here so the R1 we got as the square root of 13 I mean. So in order for us to divide this, we have to convert them to polar. So we can write this as the square root of 13 and our angle was 33.69 divided by R2 for the denominator was the square root of 29, and the angle was negative 21.8 degrees. Okay, so VT, so if you have Z is equals to R1 over theta 1 divided by R2 over theta 2, this will be equals to R1 over R2 into theta 1 minus theta 2. So now if we have to look for the VT, so we'll divide the radiuses, but for the angles, the one which is on top, the 33.69 will minus the one which is on top. So minus 21.8 degrees. This will be equals to the square root of 13 divided by, okay, the square root of 13 divided by the square root of 29, 0.669, which we can write as 0.67, and 33.69 minus will be plus 21.8. We have 55.5, so 55.49, which I rounded off to 55.5. So that's it for question 3.4. Remember to subscribe, like, and share this channel with your fellow mates. So question 3.5, we have to solve for x if x squared plus 1 is equals to 1 over 4. So one thing that I've learned is that if you solve for x with the complex numbers, you must know that the solution will be negative. So we have 1 over 4. We take this 1 to the right, is going to change sign to negative 1. So x, so we are solving for x, so x squared is equals to 1 over 4 minus 1 is equals to negative 3 over 4. So we are solving for x, so we have to introduce the square root, and when you introduce the square root, you have to include a plus or minus. So x will be equals to plus or minus the square root of negative 3 over 4. So we can write this as x is equals to positive the square root of negative 3 over 4, or x is equals to negative the square root of negative 3 over 4. So this negative is from the plus or minus. So this will be equals to the square root of 3 over 4 multiplied by the square root of negative 1. So that negative, we group it with the 1, or x is equals to negative the square root of 3 over 4 multiplied by the square root of negative 1. So x will be equals to, so that we know that the square root of negative 1, we represent it with j or I, but in most cases it's the j. So this will be equals to j for that, the square root of 3 over the square root of 4, which is 2, or x is equals to negative j for that square root of negative 1, the square root of 3 over the square root of 4, which is equals to 2. So our x will be those. So give the conjugate of 1 plus j3. So with the conjugate, all that you have to do is to change the sign of the imaginary part. So the imaginary part is a sign of positive, so the conjugate, we change the sign of the imaginary part. So this will be our conjugate 1 minus j3. So that's it for question 3. If you have any questions, you can leave them in the comment section below. And if you find these videos useful, please subscribe, like, and share this channel with your fellow mates.